Good morning, students.
Good morning, ma'am.
So all of you take your notes, ma. Write down the topic today, what we are going to discuss. Students, write down the topic potable water. In your notes, you write down potable water. On your video, students on your video. All the students on your video. So write down ma potable water. Topic is potable water. Its specifications. Its specifications. And steps involved in treatment of potable water. Write down ma. The topic is, today's topic is potable water. Its specifications and the steps involved in treatment of potable water. Steps involved in treatment of potable water. Students, you wrote, everybody? Only 54 are there today. 53. CR? Nikila? Narasimha Reddy, send one message, ma.
Okay.
Send one message to everybody because this is important topic, potable water. Only 53 are there out of 65 students.
I messaged in the group now.
Amma?
I messaged
Mm.
group la message పెట్టా.
Okay. Yesterday I have sent PPTs. You have seen, Nikila?
Yes, ma'am. I kept in the group too.
Okay, ma. Today they are only 2 topics left in the second module. So that today we are completing potable water. Monday will complete reverse osmosis. Okay, na? That also you got the PPTs. Notes also I will send you, ma.
Okay.
I didn't give you notes, no?
No, you didn't send the notes.
Also I will give you. Okay. What they are doing? Only 54 are there. Okay, we'll start our class. Let them join. Okay, na? So today's what we are going to discuss is about potable water. Potable water, it is also we can call it as, or it is also known as drinking water or municipal water. So the municipality people, for example, in Hyderabad, okay, the municipality people means every day how we are getting the drinking water in our home. So that water, the municipality people, how they are removing the impurities present in water, and how we are destroying the bacteria present in water. So some steps are involved in the treatment of potable water. So what is potable water means? That is water free from contaminants. Water free from contaminants means there won't be any impurities or any microorganisms or bacteria present in water. Okay, water free from contaminants or water that is safe for human consumption. Okay, so whatever the water we are drinking, it should be safe to us. Otherwise, we get a health problems. Okay, na? So water that is safe for human consumption is called potable water. So what is potable water means? Water free from contaminants or water that is safe for human consumption is called potable water. Students, what is potable water? Students, what is potable water?
Water which is free from contaminants or water that is safe for human consumption.
Safe for human consumption means there should not be any contaminants, any impurities, okay, in water, and that water should be safe for us for human consumption. That is called potable water. So it is also known as municipal water, or we will call drinking water. Okay. So there should be some specifications for the potable water. What we have to follow that specifications means, students, you will get this question. Okay, na? So what they will give you question is explain about specifications of potable water and steps involved in treatment of potable water. Okay, you can see the question bank. Okay, so specifications, what are the specifications of potable water means? The water should be clear, colorless and odorless. So the drinking water, it should be clear, okay, colorless and odorless. So we should not get any bad smell. We should not get any bad smell. And water, it should be colorless. Okay, it should be colorless, means there should not be like water will be brown in color or light brown in color. Okay, so the water should be colorless, odorless, it should be clear. Specifications of potable water. The water should be clear, colorless and odorless. And turbidity should not exceed above 10 ppm. Should not exceed above 10 ppm. What is turbidity means? What is turbidity in water means? Like a clay particles or any mud particles, okay, or any sand particles present in water. Okay, the turbidity should not exceed above 10 ppm in drinking water. Okay, now next third point is the hardness of water must be 125 ppm. Hardness of water must be 125 ppm, not more than 125 ppm. Okay, the hardness of water must be 125 ppm and pH must be 7.0 to 8.5. Means the water should not be more alkaline or more acidic. Okay, na? So we have to maintain the pH in drinking water 7.0 to 8.5. 7.0 to 8.5. And water should be free from heavy metals. There should not be any heavy metals present in drinking water. The water should be free from heavy metals like, for example, lead, arsenic, chromium, manganese. The water should be free from heavy metals like lead, arsenic, chromium, manganese. And also dissolved gases such as H2S and CO2. Means there should not be any heavy metals in drinking water. There should not be any dissolved gases in drinking water. So it should be free from dissolved gases like a H2S and CO2. And last point, see the students, the water should be free from pathogenic microorganisms. The water should be free from pathogenic microorganisms. So these are the specifications of potable water. So the water should be clear, colorless and odorless, and turbidity should not exceed above 10 ppm, and hardness of water must be 125 ppm, and pH must be 7.0 to 8.5. And water should be free from heavy metals like lead, arsenic, chromium and manganese, and also dissolved gases such as H2S and CO2. And water should be free from pathogenic microorganisms. So these are the specifications, ma. Everybody remember these specifications. Okay. So I gave like 5 points. I gave you specifications. So remember these. Now students, what is the first specifications, ma? 5 points I gave. What is the first point?
Clear, colorless, odorless.
Clear, colorless and odorless. What is the second point?
Turbidity
must be
not.
Turbidity should not exceed above 10 ppm. Okay. Now third point.
Hardness 125 ppm, pH
pH
7 to 8.5.
8.5. Next point. What should not be there in drinking water?
From heavy metals.
It should be free from heavy metals like, for example, write at least 2 examples, no? Heavy metals like arsenic, chromium, etc. Next, tell me, it should be free from
dissolved gases.
Dissolved gases like H2S, CO2. Next, last point. Last point.
Should be free from pathogenic microorganisms.
Should be free from pathogenic microorganisms. So this is important. Okay. So in drinking water, we have to maintain that all these specifications we have to maintain. So in drinking water, okay, na? So remember all the points. Now, treatment of water for domestic purpose. Treatment of water for domestic purpose. So municipalities have to supply drinking water or potable water. The treatment of water for drinking purpose mainly includes removal of suspended impurities. Concentrate here. Removal of suspended impurities, colloidal impurities, and harmful pathogenic bacteria. So from water, for example, you are taking a river water. Okay, you are taking a Krishna river water. From Krishna river, Vijayawada, we are getting the water till Hyderabad. Okay, and when we are taking a Krishna river water, we are doing some treatment methods here. Okay, so after treatment methods is over, okay, then we can use that water, we can drink that water. Okay, so what we are going to remove from Krishna river water, what we are going to remove means we are going to remove suspended impurities present in Krishna river water, the removal of suspended impurities, colloidal impurities like a fine particles present in water, colloidal impurities, and we are going to remove harmful pathogenic bacteria present in Krishna river water. Okay, ma? So now we collected Krishna river water. Okay, and we are going for treatment of this Krishna river water. So what we are going to remove from that water is we have to remove suspended impurities first. Suspended impurities we have to remove, like any clay or mud or anything is there, suspended impurities we have to remove. We have to remove colloidal impurities, fine particles present in water, and also we have to remove the harmful pathogenic bacteria. So these three, remember the students, what we are going to remove from Krishna river water. For example, we are going to remove suspended impurities, colloidal impurities, and harmful pathogenic bacteria. Now we are collecting sources of water. We are collecting sources of water. For example, river water we are taking. For example, okay, sources of water. First here, 5 steps are there. Steps involved in treatment of potable water. Steps involved in treatment of potable water. 5 steps are there. Listen now. First step is screening. First step, screening. Second step, sedimentation. Sedimentation. Third step, coagulation. Third step, coagulation. Fourth step, filtration. Fourth step, filtration. Fifth step, sterilization or disinfectation. Sterilization or disinfection also you can write. Disinfectation. So there are 5 steps are there, okay, in treatment of potable water. First step is screening. Second step is sedimentation. Third step, coagulation. Fourth step, filtration, and fifth step is sterilization or disinfectation. So after disinfectation process, we will store that water and we will distribute to home. Okay, now? Now first step. Students write down in your notebook, screening. Everybody write down screening. Write down. Write down screening first step. So what we do in screening, listen. Now we are taking water, raw water, river water, for example. That river water is allowed to pass through large mesh screens. So we'll take a large mesh screen. Large mesh screen. So through that large mesh screen, we are passing the water, whereby large floating matter are removed. Large floating matter. So what is that large floating matter present in water is like a leaves, okay, leaves in water, or any bark of wood, or any papers, any plastic, large floating matter, whatever is present in water, that we have to remove first by passing through the large mesh screen. By passing through the large mesh screen, we are going to remove any leaves, like bark of wood, any plastic, or paper, whatever it is there in water, we have to remove. Then second step, sedimentation. Sedimentation process also very simple, ma. Water is allowed to stand undisturbed for 2 to 5 hours in big setting tank. Means we are taking a big tank and we are passing the water in that big tank, and we should not disturb that water for 2 to 5 hours. Okay, let all the suspended particles will settle down at the bottom of the tank by gravitational force. Okay, so after 5 hours, you can collect a clear water which is rising up with the help of the pumps. With the help of the pumps, you can collect the clear water, and this insoluble impurities that is settled at the bottom of the tank, that we can remove. Okay, so water is allowed to stand undisturbed for 2 to 5 hours in a big setting tank, and suspended particles will settle down due to gravity, and clear water it rises, which can be drawn out with the help of the pumps. Okay, so this is the second step, ma. Okay, that is sedimentation. First step is screening. We are going to remove large floating matter present in water. Second step is sedimentation. We are going to remove suspended particles present in water. Now, students, tell me, what is the first step? What is the first step?
I'm screening.
Screening. What we do in screening? First step
We
also
use large
important only.
meshes.
We are
Ma'am,
going
use
to
large
remove.
meshes.
We are going to remove
No large material.
large
use
material. We
large
are going to
mesh.
remove which is there in river water. Okay, ma? So many of them will throw plastic, paper, leaves. Some leaves will be there, or any bark of the wood, like a small sticks will be there. Yes or no? Yes or no, ma? Okay, so that we are going to remove by passing through large mesh screen. What is the second step? Students, what is
Sedimentation, ma'am.
sedimentation? Ma? What we are going to do in sedimentation? This is also
We will
important.
leave water for 2 to 5 hours. The
Ah.
particles will settle down due to gravity.
Gravity.
We can,
Then
we
clear
can use
water
the
we will
water.
collect.
Yes, ma'am.
Okay, ma. Third step is also important, ma. Coagulation, right now. Coagulation. Coagulation also important. Why means? So we have to remove fine particles present in water. How to remove that fine particles from the water? The colloidal particles which we cannot see, that colloidal particles from the water are removed by using or by adding coagulants. By adding coagulants. Coagulants, we are using chemicals. You see here. We are taking in one tank water from after sedimentation process. We are taking water in tank. Okay, na? So you can see this pink color dots. See, students, you can see in this picture some pink color dots. Yes or no? Students, you can see pink color dots.
Yes, ma'am.
So that pink color dots are impurities, fine particles. Okay, na? Students?
Come on.
Pink color dots are impurities in water, fine particles in water. For example, so these pink color dots, that fine particles are, these are negatively charged clay particles. Negatively charged clay particles. Okay, ma? So you can see we are adding coagulants in the water. We are adding coagulants in the water. Okay, na? So we'll discuss now. Colloidal particles from the water, very fine particles present in water, are removed by adding coagulants. We are using the two chemicals here, okay, that are called coagulants. So one chemical name, the one chemical that is aluminum sulfate. Aluminum sulfate. And the other chemical we are using sodium aluminate. Sodium aluminate. Aluminum sulfate and sodium aluminate. So these are the chemicals we are adding in water. Third step. Okay. So these chemicals are coagulants. These chemicals are coagulants. So when we are adding these chemicals, coagulants in water, you see that aluminum sulfate, for example, aluminum sulfate in water, okay. So aluminum sulfate in water, and if we are getting what in presence of water, it reacts in presence of water, and we are getting, for example, in the water is containing calcium bicarbonate. Okay, na? So the aluminum sulfate in presence of water, we are what we are getting in the water? Aluminum hydroxide flux. Aluminum hydroxide flux. Flux means it is like a precipitate only. Aluminum hydroxide flux. So sodium aluminate when we are adding in water, again we are getting aluminum hydroxide flux. Okay, when you are taking these two chemicals, just a minute, ma. Okay, students. Now we are adding these coagulants chemicals in the water. We are getting aluminum hydroxide flux. So this aluminum hydroxide flux, it will trap the impurities. It will attract the negatively charged particles. Okay. So this aluminum hydroxide flux is positively charged. Look here, everybody, in this diagram. Okay, na? So now these is the smaller particles which are present in water, fine particles, negatively charged clay particles, for example, it will gather together to form a bigger flux. Okay, so it will convert into a bigger flux. So that can be easily settled down at the bottom of the tank, and after that we will remove by filtration. Students, look here. So this green color you can see, everybody you can see green color, that is flock. That is flock.
Yes, ma'am.
Everybody can observe the diagram. This green color one is flock. Okay, aluminum hydroxide flock. Okay, so that will trap the impurities, that will attract the impurities. Okay, you can see pink color here. Okay, that will trap the impurities, and that impurities along with the flux, that will settle down at the bottom of the tank. Okay, if you are not using coagulants, it will be remain as it is in the water. Yes, sir. Students, you are listening to me?
Yes, ma'am.
If you are not adding any chemicals here in the water, it will remain as it is, that negatively charged particles. Yes or no? That fine particles. So we want to remove that fine particles. What we are doing now, we are using coagulants. We are adding chemicals. Okay. So that chemicals, what we are using, the chemicals are aluminum sulfate and sodium aluminate. So when we are adding this aluminum sulfate or sodium aluminate, what we are getting in the water? Flux, like a precipitate only. Okay, aluminum hydroxide flux we are getting. So this aluminum hydroxide flux, so it will attract the negatively charged clay particles, and neutralization of the particle is taking place. Neutralization of the particle is taking place. Then by gravitational force, so that trapped impurities along the flux are trapping these impurities. So that together will settle down at the bottom of the tank. At the bottom of the tank. So the negatively charged particle, you can see with the cloud of counter ions. Means the other, what is there? The other ion, what is the flux here? That is positively charged aluminum hydroxide flux. So that will attract the negatively charged clay particles here. Okay. So add strongly absorbing species of opposite charge. Okay, neutralized particle with no double layer, so that will attract this. positively charged flock will attract the negatively charged clay particles. So both that will settle down at the bottom of the tank. So you can see here, coagulant forms precipitate, that green colored one. Okay, na? And it will trap the impurities. It will attract the impurities. So precipitate and trapped impurities that will settle down at the bottom of the tank. That will settle down at the bottom of the tank. So to remove these very fine particles, it is very, very important. We have to use the coagulants. Okay, we have to use the coagulants so that we can remove the fine particles present in water. Okay. Coagulation. Coagulation is nothing but converting the small particles into bigger particles. Understood, everybody? Okay. Understood, ma?
Yes, ma'am.
That is coagulation process. One more diagram also it is there here. We are adding coagulants. Impurities are there in water. Very fine particles. Okay. So it forms a precipitate. It forms precipitate, and it will trap the impurities. It will attract the impurities. So that will be settling down at the bottom of the tank. So this is the third step. Coagulation is third step. Nothing but smaller particles gather together to form a bigger flocks. So that will be settling down at the bottom of the tank. So that will be easily removed by filtration. So we'll filter. Okay. We'll filter the water, and that filtered water we will use. Okay, means we will go for fourth step. We will go for treatment of the fourth step we will do. What is the fourth step means? Fourth step is filtration. This is very simple step. Fourth step, filtration. So in filtration, we will use the sand bed. Sand bed, 3 layers will be there. Bottom layer will be gravels layer, like a small stones for the support only. For the support of this sand bed, we will take the gravels layer. Last layer is gravels layer. Small stones will be there. And you can see this layer, okay, top of the gravels layer, we will fill with the coarse sand. Coarse sand means not fine sand. Okay, ma? So we'll take a coarse sand that, okay, we can see that it is not a fine sand. It is not like a stones also. Okay, it is like a coarse sand we'll take. Ma? On the top of that, we'll take very fine sand layer. 3 layers will be there. Ma? Top layer will be very fine sand. Next layer will be coarse sand layer. And last layer will be, third layer will be gravels layer. So that we will arrange in one chamber type. Okay, we will take that layers and we'll pass the raw water on the surface of the sand bed, So then we can collect the water after passing through the sand bed. Then we'll collect the treated water. So why we have to go for filtration means, so we want to remove if any colloidal matter present in water, and we can remove some of the bacteria and microorganisms also present in water by filtration process. So water is passed through large area sand bed, and this sand bed what we are using, that may be, we can take the filter, may be pressure filter or gravity filter. Okay, we can use 2 types of filters here. Either pressure filter we can use or gravity filter we can use. So this is about filtration. So by filtration process, we can remove if any colloidal matter present in water or some of the bacteria or microorganism present in water. Okay, so this is the fourth step. Okay. Now students, tell me what are the 4 steps fast, one by one. Because the 5th step it will take time.
Screening,
Screening,
coagulation,
sedimentation, coagulation,
Coagulation.
filtration. So screening, we are going to remove large floating matter present in water. Sedimentation, we are going to remove suspended particle present in water. And colloidal impurities are removed by coagulation process. And filtration, we are doing here to remove some of the bacteria or microorganism present in water, and also if any colloidal matter present in water also we can remove by filtration process. So we will use the sand bed in filtration process. In the last step, 5th step, disinfection. Okay, so the process of destroying or killing the disease producing bacteria, the process of destroying or killing the disease producing bacteria or microorganisms, etc. from the water. Okay, so the water, if it contains bacteria, if you are killing that bacteria, so if you are doing that process, that is known as disinfection. Very simple, ma. The process of destroying, the process of killing the bacteria from the water, that is known as disinfection. Disinfection. And here, the chemicals used for killing bacteria, are called disinfectants. Okay, whatever the chemicals we are using, the chemicals which we are using for killing bacteria are called disinfectants. So what are the disinfectants we are going to use is we will discuss. So whatever the chemicals we are using to kill the bacteria, okay, that are present in water are called disinfectants. So water that can be sterilized by following method, ma. The disinfection is process can be taken by here different methods. Okay, na? So first is boiling, next is chlorination, third is disinfection by ozone. Okay, so in chlorination again we'll discuss 3 points here. So first point is boiling. Okay, now tell me what is disinfection. What is
Process
disinfection?
of destroying or killing disease by this
Process of
method.
destroying the bacteria present in water is called
Disinfection.
disinfection. So what is disinfectant? Disinfectant. Disinfection is different, disinfectant is different. Disinfectant.
Chemical which is used to destroy.
The chemicals which are used to destroy the bacteria. Destroy the bacteria are called disinfectants. So first is boiling. See the students, boiling. So this boiling, we cannot do the treatment in municipality. Okay, so they will take more water. Yes or no? Okay, so this method is very difficult. We can do at home only. Okay, we cannot do in municipality plant. So water is boiled for 10 to 15 minutes. Okay, where most of the pathogenic bacteria are killed. So when we are boiling the water at home, most of the bacteria present in water can be killed. Okay, so that's what if very means like a child or children are there in home, what they will do, they will take only boiled water only. They will give only boiled water. They won't give this water directly to them. Okay, so they will give only boiled water. Students, you will drink boiled water. You have that habit or not? No, you won't drink boiled water.
No, ma'am.
Then what you will drink?
Cold water.
Cold water you will drink. you will keep the water in the fridge,
Yes, ma'am.
refrigerator.
Chilled
Huh? Every day you will drink ice water.
Yes, ma'am. Ice water.
Every day.
Yes, ma'am.
Nikhil, what you will drink?
I drink normal water and cold water.
Normal water.
Chilled water.
Okay. How you are getting drinking water at home? Tell me now. What you are
I'll go to
using?
the-
Nikhil,
I'll go
what
to the
you are
water
using
plant.
at home?
RO purifier.
I'll go to the water.
RO
plant.
purifier you are using.
No, ma'am. No, ma'am.
Mineral
Go to the
water.
water plant.
Mineral water you are drinking.
Yeah.
Yes,
They
ma'am.
use reverse osmosis method.
Students,
Auto water, ma'am.
now tell me, all the students tell me at your home what you are using the purifier.
Ma'am, no purifier, ma'am. Water will come purified.
Purity, ma'am.
No purifier at home.
Yes, ma'am. No
You are
purifier.
getting the drinking water directly from municipality.
Yes, ma'am.
Directly. Krishna water you are getting.
No, ma'am. Water tins.
Water you are getting.
No, ma'am. From groundwater.
Borewell water you are drinking.
Yes, ma'am.
Okay, ma. See,
No, ma'am.
boiled
Potable
water
water.
is boiled water is very good, ma, for health. Okay, na, to protect our health, boiled water is good. But we won't do that at home. But if we are drinking every day some warm water, okay, it is we can protect our health. Okay, na, boiled water means when we are boiling the water at least for 10 to 15 minutes, most of the bacteria is killed, ma. That is good only. Okay, make habit. Okay, na.
It tastes very weird, ma'am.
Taste is different, huh?
Yeah.
Okay. Now next second process is chlorination. Second process is chlorination. So the process of utilizing chlorine as a powerful disinfectant as a powerful disinfectant is called chlorination. Okay. So the process of utilizing chlorine, we are using the chlorine as a powerful disinfectant. Okay. So that is called chlorination. So what is chlorination means? The process of utilizing chlorine to kill the bacteria present in water is called chlorination. We are going to discuss 3 points, students, here. 3 points. We are using bleaching powder. So in large, big tanks, we will add bleaching powder directly. Okay, na? We will add bleaching powder to kill the bacteria present in water. Okay. So bleaching powder here, it is called chemical name calcium oxychloride. Calcium oxychloride. We are adding bleaching powder in water. So what we get in water is calcium hydroxide. Calcium hydroxide and chlorine in water. Okay. So then this chlorine in presence of water, so what we are getting is hypochlorous acid, HOCl, hypochlorous acid plus HCl. So this hypochlorous acid, it is a powerful disinfectant. Hypochlorous acid is a powerful disinfectant. It will kill the germs present in water. It will kill the bacteria present in water. Okay. But here, one disadvantage you can see when we are using bleaching powder in water, what happens is, so this bleaching powder, calcium oxychloride, it will introduce hardness in water. It will introduce Ca2 plus ions in water. You can see here, calcium hydroxide in water. Calcium is there, no? Yes or no? Okay. So hardness will be increased when you are using bleaching powder in water. Automatically here you can see the calcium due to presence of Ca2 plus ions in water, increasing the hardness in water. That is disadvantage for us. Following me, students? Okay. So we should not use bleaching powder. We should not use bleaching powder. Okay. So we can get a bad smell if we are using more bleaching powder. Excess of it gives bad smell and bad taste. Students, you will drink the water if you get bad smell and bad taste?
No, ma'am.
No. Okay. So excess, we are adding excess of bleaching powder. Okay. We get a bad smell and bad taste. Okay. And also it is irritating to mucous membrane. It is irritating to mucous membrane. We can't bear that smell. Okay. Or we will get a bad taste. Okay. So now tell me, is it good to use bleaching powder?
No, ma'am.
No, we should not use bleaching powder. We have to stop using bleaching powder because you see that it is increasing the hardness in water. Increasing the hardness in water. And also if you are using excess, for example, you take some 100 liters of water. We have to add only 1 kg of bleaching powder. But people, they don't know how much they have to add. They will add 2 kg, 3 kg like that. Yes, sir, no? Those who are working in municipality, they will add like a lump sum amount they will add. They will add more kg of bleaching powder. If we are adding excess, we are getting bad smell and bad taste. It is not good for health of the human beings also. Okay. So we should not use bleaching powder.
Ma'am, but bleaching powder is still better than chlorine, ma'am.
No. Chlorine only good, Chlorine only good. Not bleaching powder. No.
Okay.
Bleaching powder increases hardness in water. Just now you can see the reaction, students. When we are adding bleaching powder in water, immediately we get lime, we will get calcium hydroxide in water. See now, reaction. Students, you can see the reaction.
Yes, ma'am.
It increases the hardness in water. It is not good. Now, second one, so that only I gave here disadvantages. We will use, still we are using, somewhere we are using now, but there are some disadvantages are there. Using bleaching powder. You can see the reaction also. Okay. So the chlorine in water, so we are getting chlorine. When the reaction is there in water with bleaching powder, we are getting chlorine. That chlorine in presence of H2O, we are getting HOCl, hypochlorous acid. So this hypochlorous acid only killing the bacteria present in water. Now the second point, students, in chlorination, we are preparing here chloramines. We are preparing chloramines, NH2Cl, chloramines. So these chloramines we are preparing by taking chlorine and ammonia. Two chemicals we are using. Chlorine and ammonia in 2:1 ratio. We'll prepare chlorine and ammonia. We are going to prepare chloramines. Okay. So when we are using this chloramine, see the students, NH3 plus Cl2 gives rise to HCl plus NH2Cl, chloramine. So these chloramines we are adding in water. Okay. So what we are getting? Hypochlorous acid, NH3 plus HOCl, hypochlorous acid. So this hypochlorous acid, it will kill the bacteria present in water. Okay. So these chloramines, it has a better bactericidal action than chlorine. So what we can discuss this point is, so it is killing bacteria very fast than chlorine. Okay, na? So it is more stable and not producing any irritating odor. Not producing any irritating odor. Okay. So these chloramines, students, we will use chloramines is useful for disinfecting swimming pools. Okay. So they will add chloramines in swimming pools. They will add chloramines in swimming pools to kill the bacteria present in water. Following me, students?
Yes,
Okay.
ma'am.
So they will use chloramines in swimming pools to kill the bacteria present in water. Okay, same theory part I gave you here. Okay, na? Hypochlorous acid, it is a powerful disinfectant that kills the bacteria. So this hypochlorous acid, it will inactivate the enzymes of bacteria and it will kill the bacteria. Okay, na? So it is more stable and not producing any irritating odor. So that we will add in swimming pools this chloramines to kill the bacteria present in water. Now last one, chlorination. Chlorination means we will add chlorine directly in water. We will add chlorine directly in water. Okay, chlorination. Now here you everybody look, you can see the slide everybody. The quantity of chlorine to be added is important here also. How much quantity of chlorine we are adding in water is very, very, very important, because if you are adding excess chlorine, so we will get bad taste and bad odor. We will get bad taste and bad odor. So how much quantity of chlorine we have to add, that is very, very important. If you are adding excess, we'll get a it causes irritation, we'll get a bad taste and odor. And if you are adding less amount of chlorine, less quantity of chlorine in water, we may not kill all the bacteria present in water. Okay, so the disinfection will not complete if chlorine is insufficient. Yes or no? Students, if you are adding less quantity of chlorine, we may not complete the disinfection process. We may not kill all the bacteria present in water. If you are adding excess of chlorine, we get bad taste and bad odor, and it is toxic to human beings also. Okay, so we have to add exact quantity of chlorine in water to kill all bacteria present in water, and also to remove the impurities present in water. Okay, so the process of applying calculated amount of chlorine to water, in order to kill the pathogenic bacteria, it is called chlorination. Okay, so the process of applying calculated amount of chlorine means we have to add exact amount of chlorine to water to kill the bacteria. Okay, so that process is known as chlorination. So here they are adding chlorine to water to kill the bacteria present in water. Now, when we are adding chlorine to water directly, so it reacts in presence of water and it generates or produces hypochlorous acid. So this hypochlorous acid, it will kill the bacteria present in water. Okay. So this chlorine is more powerful disinfectant than bleaching powder. Okay. So here what we are going to do is how to know that how much means how exact amount of chlorine we can add in water is by breakpoint chlorination. By breakpoint chlorination means we will do some experiment only here, and we can go for by taking a graph. We will take the graph. You can see here. We will take the graph. Okay, how much we will add chlorine slowly. Okay, in water, and we'll take the graph. So with the help of this graph, we will know how much exactly exact quantity of chlorine, how much we can add, we will know by this graph. Okay, so by breakpoint chlorination, we will come to know now. So how much amount of chlorine we have to add in water. So the amount of chlorine required to kill bacteria and also to remove organic matter, that is impurities present in water. So that will come to know by breakpoint chlorination. So that is known as breakpoint chlorination. Breakpoint chlorination. Okay, by breakpoint chlorination, we will come to know how much amount of chlorine we have to add. So the water sample you are taking now. The water sample is treated with chlorine. It is treated with the chlorine. Okay, and estimated for the residual chlorine in water. And estimated for the residual chlorine in water, and plotted a graph which gives the breakpoint chlorination, Now see the students, what is residual chlorine? You will get the doubt here. What is the residual chlorine? Now everybody listen. If for example, we are taking now 100 ml of water, sample of water 100 ml. We are adding 1 gram of chlorine. 1 gram of chlorine. When we are adding 1 gram of chlorine, all the impurities are removed. Okay, all the impurities are removed. When you are adding 2 grams of chlorine, then also impurities are removed. When you are adding 3 grams of chlorine, so up to 3 grams of chlorine, we can destroy all bacteria present in water. When we are adding 4 grams of chlorine, okay, 4 grams of chlorine, so that is it is excess chlorine present in water. Up to 3 grams only sufficient for us. Okay, up to 3 grams of chlorine when we are adding, all the bacteria destroyed, all the impurities are removed. But when you are adding 1 extra gram of chlorine, means 1 gram of chlorine you are adding 4 gram of chlorine. So that 4 gram of chlorine is now excess chlorine. No need for us that excess chlorine. With that excess chlorine, we'll get a bad taste and bad odor in water. Bad taste and bad odor. So that excess chlorine is called residual chlorine. That excess chlorine is called residual chlorine. Students, what is residual chlorine?
The excess of chlorine which is there in the water.
If excess of chlorine is there in water, after complete destroying bacteria, then also if any chlorine is remaining in water, if any chlorine is there in water, that excess chlorine is called
Residual
chlorine. That excess chlorine is called residual chlorine. If excess chlorine is there in water, what happens, ma? If excess chlorine is there in water,
bad taste,
get a bad taste and
toxic
bad odor. Okay, so calculated amount of chlorine only we have to add in water, because chlorine after reacts with bacteria and organic impurities or ammonia present in water, after complete reaction of chlorine with bacteria, and if any chlorine is remaining in water, that remaining chlorine in water is called a residual chlorine. The excess chlorine is called a residual chlorine. You got the point, students? Everybody? Okay, so which gives bad taste and bad odor, and toxic to human beings. It is toxic to human beings. So next class we'll discuss more breakpoint chlorination. Okay, I will explain you slowly this graph. Okay, na? Then you can understand very clearly. Then we'll discuss okay, advantages, and ozonization is there. Okay, the other method. So we'll discuss tomorrow. Students, understood my today's class?
Yes, ma'am.
Up to 4 points, 4 steps you have to understand clearly. And this chlorination, tomorrow I will revise again, and we'll discuss breakpoint chlorination. Shall I end the class?
Yes, ma'am.
Okay.
Yes, ma'am.